Thank you. It's great to be back and see several of you, people like Mr. Applegate, Mimi Bradley, Charles Weeks, who made a big important impression on me. They were able to not only do what they were supposed to do, but go beyond. And that's something that with age you really begin to appreciate. All the boring stuff's been covered. So rather than talk about me, I thought I'd tell you about some of the cool stuff I do, because it's way more cool. So I have been very fortunate to be involved in the NASA Kepler mission that's searching for planets around other stars. Now, when I first went to college, there were no planets known beyond our own solar system. When I was in a freshman seminar, the old professor was off in Antarctica doing some NSF senior review and got the young professor to come and teach his class for him the week the first planet around a sun-like star was discovered. I was kind of curious, interested, so I asked him some questions, and pretty soon I got started trying to understand how that planet got there. That was in 1995, and since that time there's been a real explosion in our knowledge about other planetary systems. It used to be it took 100 years to go from finding Uranus to finding Neptune, and now we've discovered thousands of planets just in the last few years. NASA's Kepler mission is a spacecraft about the size of a bus. It's got a mirror that's almost 1 meter in diameter, so significantly smaller than the Hubble Space Telescope. But instead of being a general purpose instrument that tries to do everything, it was launched with one purpose: to understand the frequency of Earth-sized planets. And so what it does, it stares at one patch of sky, bigger than several full moons, almost most of a constellation. And it stares at them for years and years on end, trying to detect a planet passing in front of the host star. Here's the patch of the Milky Way sky. If you were fortunate enough to be somewhere that had dark lights, back when I was in school here, there still were some dark lights in Brandon. I don't know. Maybe if you go out in the Natchez Trace a little ways, maybe you can still find some. And there's the patch of sky that the Kepler spacecraft is studying in the constellation Cygnus and a little bit of Lyra. Every image from the spacecraft looks like this. Unfortunately, it looks kind of grainy. Even the zoom-ins do. That's because it's over 100 megapixel camera, and despite this really impressive science center, or performing arts center, sorry, I suspect it's probably less than 1 megapixel for the projector. So every little smudgy fuzz thing is actually a whole bunch of stars. Millions of stars being observed simultaneously, trying to look for the rare few that have a planet that's going to pass in front of them. So what happens as the star shines light towards us, the planet orbits around it. Oh, do I have to tell it to go? Planet orbit. Orbit. Okay, well, maybe not. Let's see, do we have, well, it's okay, it doesn't really matter. Okay, so imagine a little planet following the course of the blue ellipse, passing in front of the star, blocking some of the star's light. So as we experience the shadow of this planet, the apparent brightness of a star drops by about 1/100th of 1% if an Earth-like planet passes in front of a solar-like star. If we can build a telescope that's able to detect that and distinguish it from other things going on in the star and in the universe and the instruments, we can detect those Earth-sized planets and learn a bit about them. Okay, now it doesn't even want to go forward. Can't wait. Oh, there we go.
You got it?
To give you some idea of the impact of the Kepler mission, here's a plot showing planets discovered via a variety of techniques. So the magenta circles show planets discovered around nearby stars, discovered by astronomers who go to ground-based telescopes and measure the velocity of the star over and over again, sometimes hundreds or thousands of times over the course of decades. In the light blue points, you can see a few planets that were discovered using the same method of watching planets pass in front of the stars from ground-based space telescopes. Ground-based telescopes. And then in yellow are all the planets that have been discovered by the Kepler space mission in the last 3 or 4 years. It's been an incredible journey, lots of late nights. I remember telecons at midnight on New Year's Day and saying, no, I'm sorry, I can't talk to you then because I have another telecon scheduled. What about 2 a.m., right? So it's one of those things that you have to really love because you have to enjoy that, right? And see it as, I'm so lucky that I get to be doing something like this. Okay, well, some of the notable discoveries include the fact that many planetary systems have a whole lot of planets, much bigger than the planets in our inner solar system, all crammed really close to their host star. And when the Kepler space mission launched, people didn't expect this at all. When they read my proposals to study them, they said, this is a crazy idea. We don't know of any such thing. Forget it. You don't get any money. But nevertheless, now we've found hundreds of planetary systems that have planets the size of Neptune, some between the size of Earth and Neptune that are not analogous to anything in our own solar system, all packed very close to their host star, sometimes closer than Mercury is to our sun. As a result of these and other work that we've been carrying out as part of large teams at NASA and universities across the country, we've sort of reshaped our understanding of our place in the universe. We now know that most stars have a planetary system. Maybe the philosophers have always thought that kind of sounds nice, but we've transformed it from philosophy and speculation to empirical scientific fact. We now know that planets smaller than 3 times the radius of the Earth are the most abundant planets out there. Large planets like Jupiter are relatively rare. Even Saturn and Neptune, Uranus, are much less common than planets that are more similar to the Earth. We now know that nature produces a wide variety of planetary systems. Our solar system is but one example of what can be made in the universe, and most planetary systems are wildly different. And indeed, most of them are not just different in details, but qualitatively different. And that gives you some time to pause and reflect about how our solar system fits into the other stars, the galaxy, and the universe, and our place in it. Finally, I'd like to make a pitch that anyone can join in and contribute in a really fun way. Sometimes I make this an assignment for my undergraduate gen ed students in taking an astronomy class to check some box so they can go off and study history or whatever they're interested in. But even the ones who may not really want to be in astronomy class can have some fun, because here you go and you get to look at real spacecraft data. And it's really simple. In 5 minutes you can be trained and you can go through and draw little boxes around what you think might be a planet passing around another star. Now, most of what you find will turn out to be other stars, maybe some binary stars, pulsating stars, maybe some planets we've already found. But through this planethunters.org website and citizen science approach, they've actually found planets that the computers and the Kepler science team missed. That's because despite all the wonders of technology and computers, there's still some things that a good old human eye can just recognize and go, hey, what's that? So this is really a citizen science project. It's not just about some fun little outreach to keep you busy. It's a way that people can become involved and contribute to science in a fun, engaging way. Perhaps some of you may choose to do it as yourself. Perhaps some of you may someday involve others and help give them a taste of what science is really like. One thing I disagree with is it may only be very rare that you have a flash of insight, but it can be fun the entire time. And I guess I don't really take questions now, but I always end with questions anyway. So if people would like to ask questions, I understand there'll be some opportunities later in the day, maybe after school. I bet if you find someone like Elizabeth or Mimi, maybe they can help figure out how to get us together, and be happy to talk to people individually. Thank you.